everyone, this is our CS225 presentation. Our members has Carmen, Zheng, Fred Ho, Junhan, Chen, and Jason Zhang. Our group name is CS225 Final Grade A. Our goal is to find the shortest path between two locations. We implement the open flat dataset. We used BFS algorithm, Dijkstra's algorithm, and betweenness centrality. We successfully accomplished each part, and we will discuss them in the next development slide.
What's next is our development process of the project. Data parsing is the first design decision we made by correcting the data entries that have missing information as the first step. Since the dataset of open flights is presented by DAT files, we chose to push back the DAT files to 2D vectors and then transform them into mutable maps that contain useful information for building our graphs, such as IDs and longitude for airports. And finally, we use the functions we built in the airport graph class to add airports and airlines we read from files to the graph, where airports represent vertices and airlines are edges. We also implemented several helper functions like converting string to double and int, since the built-in std and stoi functions won't provide us the accuracy of data we need for implementing our functions. Like it only retained the 2 decimal places of the original longitude and latitude.
So here comes to our BFS algorithms. Because we have used the mutable map as our structure, I have created a BFS class to better visualize the result from the BFS traversals. The private variable contains a helper function, an animation, and also a map to check whether the airport is visited. And this is also helpful for check the whether there's a cycle during the traversal. And the helper function could check whether the node is visited from a specific node, and the node is created by the get adjacent function from the airport graph. So, and also we have generated an animation as a result to visualize our BFS traversal. And also considering that the airlines could have without weight, so the BFS traversal could also output the least number of stops. And our running time is big OM plus N, and here is what we have after the BFS traversal.
The next part of a project is the shortest path and centrality between us. If you can see the code here, we chose to use the Dijkstra's algorithm and make it as a class here, with the constructor accepting an airport graph and a starting airport, which will run automatically as the object being built here. And the constructor will also store the result of the Dijkstra into the map here, indicating the previous airport for each of the airport in the airport graph. And we also provide 2 public functions here. The first one, the shortest path, will return the shortest path from the start to the destination, stored in a vector of airport in order. And the next public function, between centrality, will return the between centrality of a given airport, which is basically like how many shortest paths have passed by this specific airport. And for the runtime of our algorithm, we expect it to be n plus m times log n here, which is what we committed in our proposal. For our little challenge here, we try to build a Fibonacci heap which could possibly improve the runtime of our Dijkstra's algorithm. But due to time and its complexity, we gave up in the end. And here, let me show you guys some of our test cases for the algorithms mentioned above. Yeah, pretty good, right? So here are just like part of our test cases. We actually have more test cases in our GitHub repo if you're interested in.
So I'm going to introduce the visualization part. So at first, we found that the graph ways may be hard for us to implement our project since the graph ways only can represent the plane relationship between two nodes. So we decided to use the CS225 MP traversal animation library instead. Then we encountered another problem is that we do not know how to convert the longitude and altitude to a point. However, we find that there's an algorithm in the OpenFlight dataset that can convert the longitude and altitude. Since our graph node is represented with the airport, so we convert their longitude and altitude, then store in the X and Y value for the point.
And next, for drawing the line between the two locations, we have implemented the DDA line drawing algorithm, which we find out the steps and also the X increment and Y increment between the line. And for here, we could find out the specific point positions between the two locations in lines. And this is what we have got for our visualization.
So another challenge we encountered is how to write the makefile. We consult our TA and knew we only need to run our program in CS225 container instead of any global environment. So we decided to just use the CMake list provided by CS225 class, and it allowed us to use the command like make test and test to test our code.
So here comes to our conclusions for the whole project. So we have successfully answered the question that how to find the shortest path between two locations, and we have implemented BFS algorithm to traverse all the airports in the graph, and also the Dijkstra algorithm to find the shortest path between two locations. And our data set, we use the OpenFlight data set, and also we have created a command which the client could enter their source airport and also enter their destination airport. We will automatically generate the optimal airline for them. And also we have generated a roadmap which could visualize the result of our command. You could see it right here. So that's all for our final project presentation. Thanks for watching.